Hey everyone! Thanks for tuning in and joining us for our fourth installment of the Virtual Agronomy Den. My name is Sarah Anderson and I'm Senior Agronomist with GMAX Ag Team. And today, I'm really excited to talk to you about one of my favorite topics, soil. More specifically, how do our soils influence our agronomic decisions? So with that, let's get started. It's pretty easy to see what makes this landscape unique. The entire ecosystem of the Great Sandhills is dictated by its soil characteristics. But soil properties have just as much influence on vegetation and production capabilities in our cropland. However, as these photos show, they can be just a little bit more difficult to see on passing glance. So here at GMAX Ag Team, we believe that we need to get our hands dirty if we want to understand what makes your soils tick. There is no shortage of discussion around the ways that having a deeper understanding of our soils and their properties and landscape variability can influence any agronomic decision in a given season. But for interest of time today, we'll focus on two main ones, namely nutrient management and canopy management. Grouping areas of a field into zones is a fundamental approach in precision agronomy. But if our goal is to manage crop response to factors that are directly linked to the soil, such as nutrition management, it's crucial that these zones are built from the soil up. In the following example, samples were collected from two different zones, determined by RTK elevation, EC measurements with an EM38, and topography modeling. Soils with similar nutrient response and water holding capacity are grouped together. This Zone E soil is from a water-shedding landscape position and is lighter in texture compared to the B zone soil shown here, which is obviously much higher in clay content and has a greater probability and capacity for holding water. But just because soils look similar doesn't mean that they're exactly the same. Variability of pH is a perfect example of a soil property that doesn't follow landscape. Here are two soils that were taken from adjacent areas within the same zone, and as you can see, their pH ranges are quite different. The soil on the left is in an optimal pH range, whereas the soil on the right is arguably far too low for optimal nutrient uptake, and a lime amendment may be required. Which is exactly what we're experimenting with here. This VR lime application was only made possible through site-specific sampling. Composite zone sampling can be misleading for other nutrients as well, and can inherently mask some of the variability within a zone. Take for example zinc, shown here as both site-specific and composite sample analysis. We see in zone 9 that we missed an outlier. Granted, the composite analysis is more representative of the zone than the mathematical mean, but a zinc reading at 28.8 parts per million is worth further understanding. It could likely mean that we missed an old yard site within this zone, but that also has impacts on our fertility recommendations. In zone 10, we see the composite came back close to a full parts per million below any of the points within the zone, making zinc status look far more critical than it actually is. Another advantage of site-specific sampling is that it gives us enough statistical power to be able to correlate nutrient status with yield. And this allows us to better understand key nutrient interactions and identify which ones are driving or limiting your yield in a particular field. The data shown here, for example, shows a very strong and consistent relationship between yield and potassium availability, as indicated by positive correlations of K to Mg ratio, K base sat, and potassium baseline levels. Okay, so we've talked a lot about soil fertility already, and while there's no doubt that soil fertility and nutrient management are important drivers to crop yield, we of course cannot forget about water. Understanding where water is in the field, if it's going to stay there, and how long it's going to stay there is really crucial to our assessment of risk management, not only just for that field, but across your entire farm. When moisture is limiting, water can obviously work in our favor, but when it's too abundant in parts of the field, it can just as easily work against us. However, knowing where that water is going to be isn't as simple as an elevation map, as elevation and topography are really not the same thing. Elevation knows how far something is above sea level, whereas topography describes that landscape and how it varies and how the slope changes and ultimately where that water is going to run to. This field is a good example. The slough is pretty easy to spot, but when we look a little closer, we see that it's definitely on the top of a hill, a high hill that is holding more water than what's below it. When we bring site-specific fertility together with topography and soil type, we get a much more complete picture of resources available to that crop and ultimately achieve a better understanding of where investments should be made. These include management decisions pertaining to seeding rate and plant stand, target plant population, fertilizer recommendations, biological choices, risk of disease, lodging, and many more. Our fields are the foundation of everything we do and everything we grow. So shouldn't we get to know them just a little bit better?
Well, that's a wrap. Thanks again for joining me, especially during such a busy season. If you or any members of your farm team are interested in getting just a little bit more connected with your soils, I'd invite you to come in and speak with members of our agronomy team. In the meantime, from all of us here at GMAX, just want to wish you a safe and successful season. Take care.